Hello students, in today's lecture we will discuss a very important topic titled Nernst equation. In addition, we will study equilibrium constant from Nernst equation, electrochemical cell and Gibbs energy of the reaction. This is a very important topic from your academic as well as competitive examination. As we have seen from last few years, there have been questions from this chapter in NEET as well as JEE examinations. So I request you to listen to this lecture very attentively and note down all the important points. In the end, we will answer multiple choice questions. I welcome you once again. Nernst equation. Before we take up the discussions on Nernst equation, we have to recapitulate and recall our discussions in the previous video lecture on electrochemical and electrolytic cells. Let us quickly recap. First point, electrode potential is the potential difference set up between metal and its ions in the solution, or it is the tendency of an electrode to get oxidized or to get reduced. Standard electrode potential is the electrode potential when the concentration of all the species in half cell is unity. According to IUPAC, standard reduction potential is the standard electrode potential. Please note, standard reduction potential is the standard electrode potential. Oxidation potential. Oxidation potential is the tendency to get oxidized or lose electrons. The reduction potential is the tendency to get reduced, that is, to gain ions. Cell potential is the potential difference between two electrodes of a galvanic cell, that is, potential difference is delta E is equal to E cathode minus E anode. Finally, EMF, electromotive force, the cell potential when no current is drawn from the cell, E cell is equal to E right minus E left. So let us start. We have assumed in the previous section that the concentration of all the species involved in the electrode reduction is unity. That is, concentration is 1 molar. This need not be always true. There are cases when the concentration is other than 1 molar. Nernst showed that the electrode reaction Mn plus aqueous plus Ne minus forms Ms, and the electrode potential at any other concentration measured with respect to standard hydrogen electrode can be represented by the equation E of Mn plus 2m equals E naught Mn plus 2m minus RT over Nf natural log m, concentration of m divided by concentration of Mn plus. I will read Nernst equation once again. E of Mn plus 2m equals E naught, that is standard electrode potential Mn plus 2m minus RT over Nf natural log ln of m, capital M, divided by capital N plus. These are the concentrations. Let it be equation 1. And in this equation, here E naught Mn plus 2m is the standard electrode potential at 98 Kelvin and concentration of 1 molar. This is for 1 molar. Whereas E of Mn plus 2m is any concentration, that is electrode potential at any concentration. And 298 Kelvin is the room temperature, that is 25 degrees centigrade. R is the gas constant and its numerical value is 8.314 joules per Kelvin per mole. F is the Faraday constant and its numerical value is 96487 coulomb per mole. T is the temperature in Kelvin and capital M within big bracket is taken as unity for all pure metals and pure solids, pure elements. And Mn plus is the concentration of species. Let us take another example. Ni solid to Ni2 plus aqueous and Ag plus aqueous to Ag. This left side is the oxidation and the right one is reduction. So this reaction is, we can write this reaction as NiS plus 2Ag aqueous combined to form Ni2 plus aqueous plus 2Ag in solid. The Nernst equation for this cell reaction can be written as, please note here there are two ions. Is given by, the Nernst equation is given by E of cell is equal to E naught cell. E naught of cell, where E naught of cell is the standard electrode potential at 298 Kelvin and 1 molar concentration, minus RT over 2F. R is the gas constant. Here 2 is the value of N, which is number of electrons in the reaction. 2 into F. F is the Faraday's constant. Ln is the natural log, that is log to base E of Ni2 plus concentration of Ni2 plus concentration of Ag plus whole square. This whole square is due to the coefficient of Ag in the cell reaction shown above. Nernst equation for Daniell cell. Electrode potential for any given concentration can be written as, for cathode, that is cathode side, in the case of Daniell cell, copper is the electrode. So we are taking first for cathode. So electrode potential E of Cu2 plus 2Cu is given by equals standard electrode potential E naught Cu2 to Cu minus RT over 2F log to base E of 1 over Cu2 plus of aqueous. Here we have taken 1 because of the pure copper. The concentration of pure solid is 1, is always pure solid or pure liquid is 1. Hence we have taken value of M as 1 and the concentration of Cu2 plus aqueous as it is in the denominator. Let it be equation 2. So for anode side, we know for in the case of a Daniell cell, zinc is the anode and the reaction for electrode potential can be written as E of electrode potential Zn2 plus 2 Zn, that is it is losing electrons. So Zn, the charge is reducing, 2 plus 2 it is losing electron and it is gaining charge, equals E naught Zn2 plus 2 Zn minus RT over 2F into log to base E, natural log of 1 Zn2 plus aqueous. Let it be question 3. In anode side also there is pure zinc. Hence, the concentration of pure Zn is 1. Hence, the value is of M is 1 here also. And there are 2 electrons taking part in the reaction. Hence, the value of N here in anode side is also 2. Therefore, for anode, the Nernst equation is given by E of electrode potential Zn2 plus 2 Zn equals E naught Zn2 plus 2 Zn minus RT over 2F log to base E 1 over Zn2 plus aqueous. Let it be equation 3. Hence, the total cell potential is E cathode, electrode potential of cathode minus electrode potential of anode. So, rewriting, we can write it as E of cell is equal to E of Cu2 plus 2 Cu minus E of Zn2 plus 2 Zn. That is, this is equation summing up 2 and 3, we get this much, and further simplifying, we get E of cell is equal to E naught of cell minus RT over 2F log to base E of Zn2 plus 2 Cu2 plus. This is, let it be equation 5. It can be seen that E electrode potential of cell depends on concentration of both Cu2 plus and Zu2 plus ions. E cell increases with increase in the concentration of Cu2 plus ions and decrease in the concentration of Zu2 plus ions. So in this equation, if the concentration of Cu2 plus increases and concentration of Zu2 plus decreases, then the electrode potential increases. We can convert equation 5 in terms of natural. This equation 5 is in natural logarithms. We can convert it into the base 10 by writing the substituting the values of R, F and T. That is, putting the numerical values of R, F and T equals 298 Kelvin. We can reduce this equation in terms of log to base 10 as E of cell is equal to E naught cell minus the value of this coefficient of natural log and the value converting log to base 10, we get 0.059 over 2 into log Zn2 plus to Cu2 plus. Let it be equation 6. Please note here, we should use the same number of electrons N for both the electrodes. So the value of N here, which we have taken it as 2, should be same for cathode as well as anode. In general, for electrochemical reaction, we can write Nernst equation in another form. That is small a into capital A plus small b into capital B combined to form, that is Ne, they lose Ne minus charge and form small c into capital C plus small d into capital D. So any general chemical reaction can be written in the form small a into capital A plus small b into capital B. After reduction or oxidation, it becomes small c into capital C plus small d into capital D. And for this electrochemical reaction, Nernst equation can be written as E of cell is equal to E naught cell minus 0.059 over 2 divided by 2 into log of capital C to the power of C, capital D to the power of D. That is the product. This is the product, and reactants are, this left side are reactants. So it is capital A to the power of A into capital B to the power of B. So I will read this form once again. For general electrochemical reaction, AA plus BB forming CC plus DD, that is here the product is small c into capital C plus small d into capital D, and reactants are small a into capital A plus small b into B. And this form is E of cell is equal to E naught of cell minus 0.059 divided by 2 into log of C to the power of C, small c, D to the power of small d, A to the power of small a, and B to the power of small b, 7. Sometimes this ratio of numerator of log is written as a product P, and the denominator A and BB is written as reactant. Left side is reactant and right side is product. Sometimes it is also noted as reaction coefficient. This ratio is written as Q, reactant coefficient. Equilibrium constant from Nernst equation. We can calculate equilibrium constant from Nernst equation. If the circuit of Daniell cell shown on the screen is closed, then reaction ZnS plus Cu2 plus aqueous forming Zn2 plus aqueous plus Cus. So right hand side here, after the arrow, long arrow, right hand side arrow is the product, and the left hand side is the reactant. Let this be equation for this reaction of Daniell cell. If this reaction takes place and time passes, the concentration of Zn2 keeps on increasing while the concentration of Cu2 plus goes on decreasing. So this concentration decreases and this one increases. At the same time, the voltage of the cell as read on the voltmeter, if there is a voltmeter, keeps on decreasing. After some time, we shall note that there is no change in concentration Cu2 plus and Zn2 plus. So it is called, when there is no change in concentration of Cu2 plus and Zn2 plus, then this voltmeter will read 0, which indicates that equilibrium has been attained. In this situation, the Nernst equation can be written as, that is, at equilibrium, E of cell is equal to 0. Hence, The equation, Nernst equation, can be written as E naught of cell minus, that is, this is standard electrode potential of cell minus 2.303 into R into T divided by NF into log of K into C, where Kc is, the value of Kc is Zn2 plus 2Cu2 plus, that is the product to reactant. The ratio of product to reactant is represented by a letter K subscript C. This is called equilibrium constant. For this reaction, this is Kc is equal to Zn2 plus Cu2 plus. Hence, the equation becomes E naught of cell is equal to, taking this term on the right hand side, 2.303 into RT divided by 2F. Here in this reaction, the number of electrons are 2. Hence it is 2F into log of Zn2 plus 2 Cu2 plus. At T equal to 298 Kelvin, the above equation can be written as E naught of cell equals 0.059 V divided by volts divided by 2 into log of Kc. And this value, if we measure, if E naught of cell, if we measure, it is 1.1 volt. This is 1.1 volt, and from this we can calculate log of Kc is equal to 2 into 1.1 volts divided by 0.059 volts, that is equal to 37.288. So E naught of cell equals 37.288. That is the equilibrium constant. Logarithm of equilibrium constant Kc is equal to 37.288. So we can calculate the value of Kc by taking anti-log. So that is, we can take Kc is equal to anti-log of 37.288, that is equal to 2 into 10 to the power of 37 at 298 degrees, 298 Kelvin. Therefore, in general, we can write E naught of cell is equal to 2.303 RT divided by NF into log of Kc. This is the relationship between equilibrium constant Kc and standard electrode potential of cell. Equation 9 gives the relationship between Kc, that is equilibrium constant of reaction, and standard potential of cell in which reactions take place. Thus, equilibrium constant of the reaction, which is very difficult to measure otherwise, can be calculated easily corresponding to standard electrode potential value of the cell. Next, we will establish the relationship between electrochemical cell and Gibbs energy of reaction. The electric work done in 1 second is equal to the electrical potential multiplied by total charge passed. If we want to obtain maximum work from a galvanic cell, then charge has to be passed reversibly. The reversible work done by a galvanic cell is equal to the decrease in its Gibbs energy, and therefore, if the EMF of cell is E and NF is the amount of charge passed, then delta R G is the Gibbs energy of the reaction, and it is given by the relationship delta Rg is equal to minus NF into E of cell. Let it be equation 10. It may be remembered that E of cell is an intensive parameter, but delta Rg is an extensive thermodynamic property, and the value of delta Rg depends on N. Thus, if we write the reaction for a Daniell cell, ZnS plus CO2 plus aqueous combine to form Zn2 plus aqueous plus CO2S. That is the chemical reaction is equation 11, and here delta Rg is equal to minus 2 into F into E of cell. But when we write reaction, this reaction 2 ZnS plus 2 CO2 plus aqueous, the reaction forms 2 Zn2 plus aqueous plus 2 CuS. Then the cell reaction, if we write delta T of G equals minus 4 into F of E cell. I will read this once again. When we write the reaction 2 into ZnS plus 2 into CO2 plus aqueous forming 2 Zn2 plus aqueous plus 2 CuS give the value of delta Rg equals minus 4F into E of cell. Thus, from the measurement, if the concentration of all the reacting species is unity, then E of cell is equal to E standard electrode potential, that is equal to delta Rg is equal to minus NFE cell. Thus, from the measurement of E0 cell, we can obtain an important thermodynamic quantity delta Rg0, standard Gibbs energy of the reaction. From the latter, we can calculate equilibrium constant by the equation delta Rg0 is equal to minus RT into log of K. Let us note some important points regarding Nernst equation. Concentration cells consists of anode and cathode components that are identical except for concentrations of the reactants. That means here both anode and component and cathode are made up of same material. For concentration cell, EMF at 298 Kelvin is given by the relation E0 cell, that is standard electrode of the cell equals potential of the cell is 2.303 RT divided by 2F log of C2 over C1, where C2 is the concentration of the product and C1 is the concentration of the reactants. And here the value of C2 is always greater than C1. So, for example, for concentration platinum H2, platinum H2 to HCl and P2 platinum to H2, we can write it as a P1. The left side is P1 and the right side here is P2. So, E of cell will be equal to 0.0591 log of P2 by P1. So, we will write the equation again here. E of H plus to H2 equals E naught of H2 to H plus to H2 minus 0.0591 log of 1 over H plus. That is, I will read this reaction once again. E of H plus to H2 equals E naught of H plus H2 minus 0.0591 log of 1, that is pure hydrogen. The molality is platinum. Because of the platinum, that is inert electrode, it is 1. M is 1 divided by H plus. That equals to H plus to H2 is 0 minus 0.0591 log of 1 over H plus. That is equal to minus 0.0591 into minus log of H plus. That is simplifying. Here we can write 0 minus 0.0591 pH, that is partial pressure of hydrogen, because pH is equal to minus of log H plus 1, that is partial pressure of hydrogen. When different number of electrons are involved, then a change in Gibbs energy delta G naught 3 equals delta G naught 1 plus delta G naught 2. When we solve the numerical problems, you will understand it better. So, recalling the reaction and the relationship between delta G and E. So, if the type of reaction is spontaneous, where no external battery is connected, that is spontaneous, that is delta G is negative and the value of E is positive, and the type of cell will be galvanic. For non-spontaneous reactions, delta G is positive and E is negative, and the cell is electrolytic cell. Example, at equilibrium, both delta G and E equals 0 and it is a dead battery. We'll work out some examples. Question number 1. Represent the cell in which the following reaction takes place. Mg and 2Ag plus react to form Mg2 plus 2Ag. Here, calculate its E cell if E naught cell equals 3.17. Please note from the screen that the concentration of Ag is given as 0.0001 m and the concentration of Mg2 plus is given as 0.130 m. So we have to calculate the electrode potential of the cell if the E naught cell, that is standard electrode potential of the cell, is given as 3.17 volts. The cell equation can be written as Mg2 plus with concentration 0.130 m, and on the right hand side Ag plus 0.0001 m to Ag. So E of cell is equal to E naught of cell minus RT over 2F into natural log Mg2 plus divided by Ag plus 2. Because here there are two ions of Ag are involved in the reaction. So 2 ions of Ag plus are involved. And in the consolidated form of the equation can be written as E of cell is equal to E naught cell minus 0.059 of 2 into log of Mg2 plus divided by Ag plus whole square. Concentration of Mg2 plus and Ag2 plus whole square. Substituting the values of concentration, we can write E naught cell is equal to 3.17, it is given, minus 0.0592 into log to base 10 of Mg2 plus. The concentration of Mg2 plus is given as 0.130 m. So it is written in the numerator 0.130 divided by the concentration of Ag. Ag is 0.0001 to the power of 2 because two molecules of Ag are involved in the reaction. Therefore, simplifying, we get the value as 3.17 volts minus this value becomes 0.21 volts, that is equal to 2.96. Next question. Calculate the equilibrium constant of reaction CUS combining to form 2Ag plus aqueous to give Cu2 plus aqueous plus 2Ag plus, and it is also given as E0 cell is equal to 0.46 volts. So I will read the question once again. Calculate the equilibrium constant of the reaction. Cu2S combines with 2Ag plus to form Cu2 plus 2Ags, and E0 of cell is given as 0.46. So answer E0 of cell is equal to, using the formula, E0 of cell is equal to 0.059 volts divided by 2 into log of Kc. Kc is the equilibrium constant and we are required to find the equilibrium constant from the question given and asked in the question. So that is equal to E0 of cell is given as 0.46 volts equals 0.059 volts divided by 2 into log of Kc. So log of Kc is equal to 2 into cross multiplying 0.46 volts divided by 0.059 volts. Simplifying, we get the value as 15.6. Log of Kc is equal to 15.6. So to find Kc, we have to take the anti-log. So Kc will be is equal to anti-log of 15.6. From tables, you can write that anti-log of 0.663.92 into 10 to the power of 15. This is applying standard log and anti-logarithmic table method. Next question. The standard electrode potential for Daniell cell is 1.1 volts. Calculate the standard Gibbs energy for the reaction. ZnS plus Cu2 plus aqueous forming the product Zn2 plus aqueous plus CuS. Now we have to use answer. We have to use the formula delta Rg is equal to minus Fe E naught minus NFE naught. N in the above equation is 2. Here you see there are two electrons in both the sides. So therefore F is equal to 96487 coulombs per mole and E naught cell is given as 1.1 volt. Therefore, delta Rg naught is equal to N F E naught, that is equal to minus N minus 2 into 1.1 volt into 96487 coulombs per mole. So that becomes minus 21227 joules per mole or 212.27 kilo joules per mole. So now we will answer multiple choice questions. Here the question and possible answers are given. You have to identify the correct answer and mark it. So we will take up MCQ1, that is first multiple choice questions. At 25 degrees centigrade, Nernst equation is, please read the table. Option A, E cell equals E naught cell minus 0.059 divided by N into log of ion on the right hand side divided by ion on the left hand side. Option B is E of cell is equal to E naught cell minus 0.059 divided by 9 into log of M on the right hand side divided by M on the left hand side. Option C is E of cell is equal to E naught cell plus 0.059 N into log of ion on the right hand side divided by ion on the left hand side. So option D is E of cell is equal to E naught cell minus 0.059 N log ion of left hand side over ion on right hand side. So please read the sentence and choices. Pause the video, read the question and mark your correct answer. So the correct answer is A. MCQ 2. For a cell reaction Mn plus aqueous plus Ne minus forming Ms, the Nernst equation for electrode potential at any concentration measured with respect to standard hydrogen electrode is represented as. Four options are given. Please read option A, B, C and D. Option A, electrode potential of Mn plus to M equals E naught Mn plus to M minus RT over Nf into log to base E 1 over Mn plus. Option B, E of M to Mn plus equals E naught M to Mn plus minus RT over Nf into log E Mn plus divided by M. Option C, E of Mn plus to M equals E naught into E naught of Mn plus to M minus RT over Nf log to base E 1 over M. Option D, E of Mn plus to M of E equals E naught Mn plus to M minus RT over Nf into natural log Mn plus. So please pause the video, recall what you have studied and mark the correct answer. It is just remembering the correct formula. The correct option is A, because for pure solid, a pure electrode, pure solid, the M value of M in the numerator is 1. Next question. Mark the correct Nernst equation for the given cell. FeS to Fe2 plus of concentration 0.001 M and H plus 1 M 1 molar to H2 gas to 1 bar of platinum. Inert electrode is platinum. So you have got four options. E cell is equal to E naught cell minus 0.059 divided by 2 into log to base 10 of Fe2 plus of H2 to the power of 2 divided by Fe H2. Option B, E cell equals E naught cell minus 0.0592 divided by log of FeH2 to the power of 2 Fe2 plus H2. Option C, E of cell is equal to E naught cell minus 0.059 divided by 2 into log of concentration of Fe2 plus H2 divided by Fe, concentration of Fe, H2 2. And the final choice option is A cell is equal to inert cell minus 0.0592 divided by log of Fe of H2 divided by Fe2 plus H2 2. So you have to write the equation and the correct identify the product and reactants correctly. At anode, the reaction is FeS forms Fe2 0.001 m plus 2e. That is, it loses 2 electrons. And at cathode, 2H of 1 molar concentration gains 2 electrons and forms H2 hydrogen gas at 1 atmosphere. So therefore the net reaction is Fe plus 2H. Fe plus 2H forms Fe2 plus H2. So these two electrons get cancelled. The next equation for this is E of cell is equal to E naught of cell minus 0.059 divided by 2. That is, product is Fe2 plus H2 divided by reactants is Fe plus 2H. 2H can be written as H square to the power of 2. Mark it. Option C is the correct answer. Next question. The correct Nernst equation for the given cell is PTS Br2L to Br minus M and H plus M H2 gas at 1 bar PTS is, four options are there which are displayed on the screen. Here examine this equation and see that the platinum is an inert electron and this cell reaction can be written as the chemical reaction at anode 2Br minus L emits 2 gets oxidized and emits 2 electrons. So it becomes Br2 M plus 2E. At cathode 2H plus M gains 2 electrons, reduces to hydrogen gas. Equating the coefficients, we can write 2H plus 2Br minus forms Br2 plus H2. So here the product is Br2 plus H2 and the correct Nernst equation is option A. Please mark it. Next question. What will be the EMF of the following concentration cell at 25 degrees centigrade? AgS to AgNO3 of concentration 0.01 molar, AgNO3 0.05 m and Ag to Ags. So here, because it is a concentration, the electrodes in both the cells, half cell is same, electrode and reactants, but the concentration differs from the reactant to the product. Four options are given. 0.828 volts, 0.0413 volts, minus 0.0413 volts, and option D is minus 0.828 volts. So here we have to do some explanation. We know that E is given by E electrode potential equals E naught cell minus 2.303 RT divided by N log of Kc. But E naught of cell is 0 for all concentration cells. So it is given that it is a concentration cell. So E naught is 0 here. Therefore, substituting E naught cell is equal to 0 minus, this is 0.0591 divided by N. So the number of electrons acting are 1 only. Therefore, that is equal to log of 0.01 m divided by 0.05. That it becomes 0.0413 volts. Please mark it. Next question. What will be the reduction potential for the following half cell reaction at 298 Kelvin? Given Ag plus is equal to 0.1 molar and E naught cell is equal to 0.80 volts. Four options are given and you have to make some calculations. The given equation can be written as Ag plus gains one electron to form Ag. Therefore, E cell, half cell cathode cell, EF cell is equal to E naught cell minus 0.059 divided by 2 into log of 1 over Ag plus. So here, because it is pure silver, the M is 1. Therefore, it can be written as 0.80, which is given, E naught is given, 0.059 divided by 2 into log of 1 over 0.1 m is the given concentration of Ag plus. So simplifying and finding the logarithmic value, we get the answer as 0.741 volts. So answer A is the correct answer. Please mark it. Next question. Mark the correct relationship from the following. So four relationships are given. Log K is equal to NFE divided by 2.303 RT, and EMF of cell is ZNS and ZN2 plus A1, CU2 plus A2, and CUS is EMF is E naught cell minus 0.0591 divided by 2 into A2 over A1. Nernst equation is also given in terms of product and reactants. And option D for electrodes, Mn plus E to M at 298, E is equal to E naught plus 0.591 divided by N log of Mn plus. So you have to explain and mark the correct relationship. You have to remember the formula and mark that the correct Nernst equation is given by E cell is equal to E naught cell minus 0.0591 divided by N log of products into divided by reactants. Next question. For the cell reaction 2Cu plus aqueous, the product is CuS plus Cu2 plus aqueous. The standard cell potential is given as 0.36 volts. The equilibrium constant for reaction is, four options are given. Option A 1.2 into 10 to the power of 6. Option B 7.4 into 10 to the 12. Option C is 2.4 into 10 to the power of 6. Option D is 5.5. 10 to the power of 8. Please pause the video and work out and give the correct answer. Meanwhile, I will give my calculations. So log of C, we know the formula. Apply the formula. Log of Kc is equal to n into E naught cell divided by 0.0591. For the given cell, n is equal to 1. Therefore, log of Kc will be equal to 1 into 0.36 divided by 0.0591. That is equal to 6.09. So Kc, if you want to find out Kc, we have to take anti-log. So Kc is equal to anti-log of 6.09. So that is equal to 1.2 into 10 to the power of 6. So option A is the correct answer. Please mark it. Next question. E naught of cell for reaction 2H2O forms H3O plus OH minus at 25 degrees centigrade is minus 0.8277 volts. That is standard cell potential. The equilibrium constant for the reaction is, four options are given. Please read all the four options and you have to make some calculations. Please do it, pause the video, do it yourself, and I will simultaneously give the explanation. It is given that 2 of H2O forms H2O plus OH minus. Therefore, E naught of cell is equal to 0.0591 divided by n into log of k. Therefore, log of k is equal to n of E naught cell, standard potential divided by 0.0591. Substituting the values, 1 into minus 0.8277 divided by 0.0591, that is equal to minus 14. Hence, k will be equal to anti-log of minus 14. That will be equal to, k will be equal to 10 to the power of minus 14. So option A is the correct answer. The cell reaction is spontaneous when E naught of reduction is negative, delta G naught is negative, delta E oxidation naught is positive, and delta G naught is positive. Please read the options once again. E naught red is negative, delta G naught is negative, E naught oxidation is positive, and delta G naught is positive. Please read the question and remember and mark the correct answer as B. So for reaction is spontaneous when delta G naught is negative. Free Gibbs change in free Gibbs. Delta G naught for the cell with cell reaction ZNS plus Ag2O, both solid in solid state, plus H2O in liquid state forms Zn2 plus aqueous plus 2Ag solid plus 2OH minus aqueous. Given that E naught of Ag2 to Ag is 0.344 and E naught of Zn2 plus to Zn as minus 0.76. So we have to find the value of delta G naught. Four options are given. A 2.13 into 10 to the power of 5 joules per mole. Option B, minus 2.13 into 10 to the power of 5 joules per mole. And option C, 1.06 into 10 to the power of 5 joules per mole. And option D, minus 1.06 into 10 to the power of 5 joules per mole. So we have to work some numerical analysis and give the answer. So E naught of cell, we know that is equal to E naught of cathode minus E naught of anode. So E naught of cell is equal to E naught of Ag2O to Ag minus E naught of Zn2 plus Zn. Here Zn2 is anode. So E naught of Ag2 plus Ag is given as 0.344 and E naught of Zn2 plus Zn2 plus to Zn is minus 0.76. Substituting the values, we get here minus of minus, it becomes plus. So it is E naught of cell is equal to 1.104. So we have to use another formula. Delta G naught is equal to minus FNF into G naught, delta G naught into delta E naught, delta G naught into E naught. So that is equal to, here in this reaction both right and left hand side, N is equal to 2, that is equal to delta G naught is equal to minus 2 into the value of F is 96500 approximately into E naught of cell is 1.104, that is equal to minus 2.13 into 10 to the power of 5 joules per mole. Please mark it. It is given as option B. E naught values for the half cell reactions are given below. Cu2 plus E, that is reduction, gives Cu plus, and for this cell E naught is 0.15 volts. Cu2 plus 2 is gives Cu and E naught is 0.34 volts. What will be the E naught of the half cell Cu2 plus E minus? Cu plus E minus. Please read the question once again. E naught values for the half cells are given. And what will be the E naught of half cell Cu plus E minus forms Cu? So four options are given: plus 0.49 volts, B 0.19 volt, C 0.53 volt, and D 0.30 volts. All are positive. So you have to calculate. So Cu2 plus E minus gives Cu. E naught is given 0.515 volts. So delta G1 naught comma N1 is equal to 1. For this N1 is equal to 1. Cu2 plus 2E E naught 2 is equal to 0.34. So here delta G2 naught N2 is equal to 2. So we have to take two different values of N1 and N2. Therefore Cu plus E minus is equal to Cu is equal to E naught 3 we have to find, and delta G for delta G3 naught is N3 is equal to 1 here once again in this equation. That is the question asked. So therefore we have to substitute in formula delta G3 naught equals delta G2 naught minus delta G1 naught. So for G3 N3 is equal to 1 Fe 1 Fe E3 naught is equal to minus 2 F N F E2 naught minus N1 F E naught. So that is equal to 2 times, because N2 is equal to 2 is equal to 2 times 0.34 volts minus 0.15 volts. That is equal to plus 0.53 volt. This answer is given as C. Please mark it. Next question. Delta G naught for the reaction Cu2 plus Fe forming Fe2 plus Cu is given by E naught Cu2 to Cu2 plus to Cu is 0.53 volts and E naught Cu2 plus Fe equals 0.44 volts. 11.44 options are 11.44 kilojoules, B 180.8 kilojoules, option C is 150.5 kilojoules and option D is 28.5. So you have to calculate. E naught of cell is given by E naught of Cu2 plus Cu to Cu minus E naught of Fe2 plus to Fe. So it is given as 0.34 and for anode it is minus of 0.44. So that becomes 0.78. So delta G naught is minus NF into E cell to the power naught. So multiplying here N is 2. So minus 2 into 96,500 into 0.78 and that is 150.5 kilojoules. Please mark it as C. With this we come to the conclusion of Unit 2 Lecture 2. Next will be Unit 2 Lecture 3 where we will discuss about conductance of electrolytic solutions, electrolytic cells and electrolysis. Till then, goodbye.